Hello my friends, welcome to today's video. So in this video we are going to talk about how electrons are arranged in the main energy level or orbit or in the sublevel. So today in this video you are going to learn electronic configuration. So let us start. So first we are going to talk about Bohr's atomic model. So what basically Bohr's atomic model is, it was published in 1914, and in that atomic model there is a nucleus and orbits, right? So according to the Bohr's atomic model, electrons are present in the orbit, right? So for example, there was a one formula. If you want to find out what is number of electron present in the first orbit or first energy level, then there was a formula like 2n square. What is n? Here n is equal to energy level. So as per the formula, if I will take n is equal to 1, and if I will put in this formula, so it will become 2 into 1 square. So answer is coming 2. So maximum number of electron that can occupy the first orbit is 2. Now if I will take n is equal to 2, then it become 2 into 2 square, then it become 8. Okay, so second orbit, it can its a capacity of electron is 8. So if I'm indicating that electron by cross or dot, then I can indicate it in this way. Right? Now let me move to the n is equal to 3, means third orbit or third energy level. So it becomes n into 3 square, that is 18. Right? Similarly, means the next orbit, it become 18. Now if I will take n is equal to 4, energy level or main energy level is 4, then 2 into 4 square, so it is coming 32. So these are the electrons that can occupy in the main energy level. Now what is happening next is, these energy level can split into sub-level. So let me just write down here sub-level. So if you are taking n is equal to 1, it means that it can split into one sub-level. So that sub-level we call it as a S. If I am taking n is equal to 2, means second energy level, that is this one, then it can split into two sub-level, that is one is S and another is P. Next will be third main energy level, and that third can split into 3 sub-level. Okay, so it become S, P and D. So for example, S sub-level, it can take 2 electron. That is the first one, you can see here. The second one, second main energy level, it is splitting into 2 sub-level. So one is S, one is P. So S orbital, we call it as a orbital, sub-level or orbital. So it can take 2 electron and P can take 6 electron. Now total, see this, it is coming 8. Now the next one, n is equal to 3. Now if I will take n is equal to 3, then it is splitting into 3 sub-level, SPD. Now S, there is 2 electron. P, in the P orbital or P sub-level, there is a 6 electron, and in the D there is a 10 electron. So see this, total is coming 18. Now if I will move ahead, then if I will take n is equal to 4, then it will become S, P, D and F. So I will just erase this one, and I will take the example of n is equal to 4. Okay, so let me take it here. N is equal to 4. So as per this formula, it become a 4 square, it become a 32, and it can split into, because energy level is 4, so it can split into 4 sub level S, P, D and F. Now S orbital 2 electron, P orbital, P sub level or orbital, it have a 6 electron, D that is 10 and F that is 14. So these orbitals or sub level having a reason, or we can say that it is a space. For example, let me talk about S orbital. So S orbital is a spherical shape like this way. This is the S orbital. Its shape is like this. This is the S orbital, which is a spherical in shape. Now if we are talking about P orbital, then P orbital is a dumbbell shape. Okay, so P, let me just draw the, so let me just write down here P orbital. So its geometry is like a dumbbell shape. Okay, so how dumbbell shape? So for example, let me draw it here. So it is like this way. Does it look like dumbbell? Yeah. So this is your x-axis, this is y, no, this is z, and this one is y. Yeah, this one. So this is called as px, because p orbital have a 3 orientation, 3 direction. It have a px, py and pz. So for example, I have shown here is px, right? So I will show you py as well. So in case of py, it is like this way. So it is like this way. Yeah, so here is your x, then this one is your z, and this is your y. So this is, we call it as a py. And pz, now pz, it will be like this. Yeah, 3 direction, 3 orientation we say it is a, so this is your x and this is your y. So this is called as pz. These means these 3 that is sub level, we say. Yes. Now so similarly, you have a d orbital also having a shape, and f orbital also having a shape. Now your electron is present in the sub level, and probability to finding out electron in the sub level is maximum, because electron is moving. So there are 95% chances are there you can locate or you can find that electron. I hope this is clear to everyone. So I will just erase this one and we'll just move ahead. Okay. So now, next is about up-bow principle. That is very important principle. We say it is a up-bow principle. Yeah. So in German, up-bow is called as, meaning of up-bow. This word is a building up. Building up. So it means that the lower energy, the one which have a lower energy, that will fill up first. Since electron first will occupy in the lower energy level, then it will move up, higher energy level and all like that. So here if I will, so suppose that on y-axis this is the energy. So first you will get 1s. Yeah, 1s. What is 1? 1 is your orbit, that is main energy level, and s is the orbital or sub-level. Next will be, you have a 2s, and next will be 2p. Yeah, 1s, 2s, 2p. Because see that second energy. So these numbers are indicating the main energy level or orbit. So as we have seen that the second energy level, it contains two orbitals, two sublevels. So this is 1s and 1p, right? So if I will move to the third one, so first you just write 1s, 2s, 3s, 4s, 5s, 6s, 7s also you can write, and above 2s you can write here 2p, and above 3s write down 3p, 4p, then 5p, 6p. Okay, then next will be 3d. Okay, so 3d, 4d, 5d, 6d. Next will be 4f, 5f, 6f. So first, the lower energy level, the one which is very close to its nucleus, that is first orbit, right? And it have a lower energy. So as we away from the nucleus, the energy of that energy level will increase. So 1s, then you have 2s, 2p, like that, 3s, then 3p, 4s, 3d, 4p, 5s, then 4d, 5p, 6s, then 4f, 5d, 6p, like that. Yeah. So this is the order of orbital. Here this number is indicating about energy level, and this later is indicating the orbital or sublevel. So if I will take the example of hydrogen, its atomic number is 1. So in that case I will write down its electronic configuration is 1s, and there is only one electron, so I'll put it 1 here. So 1 is indicating the main energy level, first orbit, s is indicating the orbital or sublevel, and 1 here is indicating the electron. So you can also represent that orbital by box. For example, in case of s orbital, you can put only one box, and that one electron you can show it by arrow. So yeah, like this way, half hooked arrow, like this way you can indicate that electron. Next, if I will take the second example, like helium is 2, atomic number is 2. So in that case it will be 1. Again I will start from here. 1, lower energy first, 1s. There are 2 electrons. Yes, 1s, 2. Right. So again for s orbital I will put one box. Right. It have only one direction, spherical in shape, and there are 2 electrons. So one electron I will show you like this way, and another electron I will show you by upward and downward. So one is showing you clockwise because one electron will move in a clockwise direction, another electron will move in anti-clockwise direction. So this is called as Pauli exclusion principle. Like what I'm saying is Pauli. There is another principle, Pauli, we have discussed above. Pauli exclusion principle. So what this principle is saying that if there is two electrons present in the same orbital, same orbital or sublevel, two electrons, then these two electrons will not have a same quantum number. Because I have not discussed quantum number here, but I am using that word quantum number. So, or in another word, if there is a two electron present in the same orbital, atomic orbital, then one electron will move clockwise and another electron will move anti-clockwise. This is called as Pauli exclusion principle. Okay. Or if there is two electrons, then they don't have a same quantum number. They will have a different quantum number. So there are 4 quantum numbers. With the help of that, you can find out electron position. So for example, this one is called as principal quantum number. 1 here, 1, 2, 3, 4, 5, 6, whatever is numbers are there, that is called as principal quantum number or your main energy level. And then these alphabets are there, letters are there, S, P, T. These are the we call it as sublevel or atomic orbital or azimuthal quantum number. Yes. So let us move to the next one, that is lithium, third element. Lithium, as per the increasing number of as per the increasing atomic number, sorry. So third. So again, the first one, lower energy level, 1s, 2, 1. Then it will move to the next energy level, which is the 2s, right? 2s, 1. So 2 plus 1, 3. That's over. Again, for s orbital, you can put one box, only one direction, right? So this box is indicating that orbital. Again, I am repeating. Sorry for that. And there are 2 electrons. So one electron clockwise and another electron anti-clockwise. Over. Now you can move to the 2s1. So again, for s orbital, one electron is there. You can show it like in this way. So this is the electronic configuration of lithium.